This video shows you how to use the FSP pin configuration function for RZT and RZN devices. It teaches you how to set up pins and shows examples of pin conflicts. It also shows the pin setup when it's done, so you can check your work. In the first part, we will introduce the RZ pin configuration for you. The process of pin configuration is similar in both E-Square Studio and FSP Smart Configurator. Hence this video tutorial will show the procedure using E-Square Studio. To begin, navigate to the project tree and double-click on the configuration XML file. Next, click on the Pins tab to directly access to the pin configuration. Alternatively, you can configure pins via the property settings in the Stacks tab, like shown in the following. For example, we add a SPI peripheral driver by clicking on Stacks tab, then clicking on New Stack, choosing Driver, Connectivity, and finally clicking on SPI driver on our SPI. The Pins tab can be accessed by configuring the pins in the SPI's properties. The pin configuration toolbar area includes three main sections. The Select Pin Configuration section includes features to manage pin configurations, export to CSV files for pin modifications and disable warnings for pins with no drivers. The second pin selection section is offering flexible pin configuration through ports or peripherals. Finally, the pin configuration section allows users to configure various pin-related properties. To work with different pin configurations, click Manage Configurations to open the Manage Pin Configurations screen. Here you can check existing pin modifications, add new pin modifications, or import an external pin file. In the pin selection field you can select the port pin number in the port subsection to configure device pins. This process involves choosing properties such as symbolic name, mode, output type, drive capacity, region, Schmidt trigger, slew rate and input-output. Besides, pin function also can be configured through peripherals subsection. For instance, with SCI peripheral channel 1, you can configure pin group selection, operation mode, and input-output. In addition, when you want to quickly group pins, you can choose Cycle Pin Group. This button by default indexes through the available port assignments automatically, in hope that certain combinations will result in no assignment conflicts. After clicking Cycle Pin Group, the SCI driver's port pin will switch between pin groups in the pin configuration section. The GUI in E-Square Studio or FSP Smart Configurator offers FSP visualization, showing an emulated package for the device including unused pins and conflict pins. In case this view is not visible, you can find it under the C++ section in Renesas Views. This view is not only providing a visualization of the pin assignment locations, it also allows assignments to be done directly on the pin. All pins are colored according to the pin function category colors shown in Legends section. You can configure pins in the FSP visualization by click on the circular pin symbol. You can simplify the confirmation of pin assignments by selecting various attributes from the pull-down menu. To do this, click on Pin function in the toolbar area. In the FSP visualization view, you can switch between the module name and the symbolic name. In the second part, we will introduce you to the features available in the Pin Configuration GUI. This section will show you how to set up a pin without referring to the hardware user's manual. In a normal approach we use the manual for finding details about a pin's function, its related module, port allocation, and supported package. However, This process can slow down your work when searching for materials and locating this information. Fortunately, eSquare Studio provides a convenient pin configuration tool that you can utilize to check and set up port pin functions. Returning to the Pins tab in the FSP configuration, click on the Pin Number tab. The table shows the pin name with its selected function and direction. The field pin name includes the port pin number and all of its function options. You can assign a concrete functions in the function column. You can switch the pin configuration to the table view by selecting Matrix View. This view is similar to Pin Number tab, but it provides enhanced functionalities and organized the function according to peripherals instead of lumped together. For instance, MISO2 and MOSI2 pins, which are the transmission and reception data pins of SPI driver channel 2, will be set up. The SPI column title should be clicked to place an order. Scroll down to find these pins. It can be seen that the port pin P186 can be assigned for SPI MISO2. Next, by clicking on the cell in function column, a pull-down menu will appear. Simply choose the pin function that needs to be set, such as SPI MISO2. Use the same method for the SPI MOSI2 pin. Now, both pins are configured and ready to use with eSquare Studio, without the need to check any additional materials. This matrix table view also allows moving column by dragging and dropping to enable a dedicated focus on the current pinning. Moreover, a certain row, column, or cell can be freezed in place, similar to an actual spreadsheet. This function can be accessed by right-clicking on any row, column, or cell. For a quicker configuration process, you can search for a pin function that you want to configure by typing the pin function name, such as SPI MISO2, into the toolbar's filter text. The third part of the FSP pin configuration provides an example of pin configuration conflict and the guidance for users on how to check and resolve it. In this example, the LQFP128 pin package is selected first and we use the CANFD and IIC drivers for illustration. The CANFD driver is configured with the pins as follows: pin P52 for CANRX0 and P53 for CANTX0. The IIC driver has its pins configured in a disabled state. Then, the IIC driver is enabled and its pins are configured as follows: pin P52 for IIC SCL1 and P53 for IIC SDA1. As a result, error messages are displayed because the same pins are being used in both CANFD and IIC drivers. Maintaining the CANFD driver's pin setup, the pin configuration of the IIC module is modified as follows: pin P211 for IIC SCL1 and P212 for IIC SDA1. However, these error messages still appear, even though the IIC module has been configured with different pins than the CANFD module. The reason is that both pins P211 and P212 are already in use by another module. Users can check for conflicting pins during configuration by accessing the Pin Number tab. Conflicting pins will be highlighted in red, as shown in the example. Additionally, users can also check for conflicting pins through FSP visualization. All conflicting pins during configuration will be highlighted in red, as shown in the example. To resolve this issue, you can choose another device with more pins, like the 176-pin LQFP package in this case. Configure the pins for two drivers, CANFD and IIC. The CANFD driver retains its configuration, while the IIC driver is in a disabled state because of the previous pin conflict. Following that, retain the CANFD driver's pin configuration as is and enable the IIC driver with the following pin configuration: P52 for IIC SCL1 and P53 for IIC SDA1. This results in a warning due to a conflicting pin configuration between the two drivers. In the 176-pin package, there is an option to configure the IIC driver pins as P22.6 and P22.7. Reconfigure the pins for the IIC driver as follows: pin P22.6 for IIC SCL1 and P22.7 for IIC SDA1. As a result, the pin conflict error has been resolved and you can use this configuration. Besides pin conflicts, you may encounter other common issues during pin configuration. You have configured the IIC driver on the Pins tab. However, on the Stacks tab, the stack for the IIC driver has not been added yet. Warnings result from configuring IIC driver peripheral pins in the Pins tab without an associated driver in the Stacks tab. If you want to use the IIC driver, please add it from the Stacks tab. If you do not use the driver, but use a driver created by yourself, you can remove this warning. Here's how to do it. To disable the warnings, you can utilize the integrated Configure Pin Driver Warnings feature. Following that, add all necessary pin functions to be disabled to get no warnings to the No Driver Pin functions. As a result, the previous warnings disappeared. The fourth section will provide you with information about the output of pin configuration. After the pin configuration process has been completed, the configured content can be automatically generated by clicking the Generate Project Content button located in the top right corner. The content of the configured pins is included in a structured data set. The name of this data set is determined based on what you input in the Generate Data field. For example, it could be named GBSP pin CFG. In addition, users can check the pin's content in the pindata.c file in the project tree. This content is declared in a struct data type. These pins are also defined in BSP pin CFG.h header file. Finally, we'll explain how the pin content is initialized when the device starts up. Using the Blinky project as an example, where pins are configured. When the device is powered on, all configured port pins are initialized by invoking RIO port open in the RBSP warm start function as part of the startup process.